Hi guys, I hope all are doing good. So as I've already told you people that I'll be starting with compiler design initially. So first let's discuss about the syllabus. So in syllabus we have first the lexical analysis and then the parsing, SDT, which means the syntax directed translation, the runtime environment, intermediate code generation, local optimization, and data flow analysis. So under this data flow analysis, we have constant propagation, liveness analysis, common sub-expression elimination. So these are the syllabus that we have. Okay. So first, let's understand what a compiler is. So a compiler is something that converts a high-level language to a low-level language, meaning it converts a high-level language to an assembler language, you can say. Okay. So we had someone called John Backus. Okay. So he took 18 years to introduce the first complete compiler. So to introduce the first compiler, he took 18 years in the year 1957. But today, people are doing this complete compiler, designing everything within 4 months itself. But back then, it has taken 18 long years to just introduce the first compiler. Now, let's understand. So to build a compiler, what knowledge is required? So, the first and foremost is the programming knowledge you require. So in programming language, we have parameter parsing, scope of variables, memory allocation, etc. Next, we need theoretical knowledge, in which we have automata, context-free grammar, and etc., which comes under the concept TOC. Okay. So then comes the algorithms and the data structure. So in this we have hash tables and the graphs, algorithms, dynamic programmings, etc. Then comes with the computer architecture and then the software engineering. So to build a compiler, what knowledges we require? The programming language, theoretical knowledge, algorithms and data structure, computer architecture, and software engineering. Next, we'll discuss about what an interpreter is. Okay. So, what is interpreter? Interpreter is nothing but which works similar to compiler itself, but it is mostly like a lexical, syntax and semantic analysis. Meaning it will include the phases of lexical, syntax and semantic analysis. So we have 3 different types of analysis. So these analysis will be included in this interpreter. So in simple words, if you want me to explain what interpreter is, in compiler, if you write a code, imagine you have written a line of code. Okay. So you have written a line of code. So you have written some, imagine some 8 or 10 lines of code. Now, what compiler does is, it executes this complete set of code at once. At once, the compiler executes this complete set of code. But what interpreter does is, each line it will execute. Each line it will run. So, you know what happens? Each line when you are running, it takes a lot of time for an execution part. And that's what interpreter actually does. So here you can clearly see it's performed for each single statement. And when the statement is error-free, instead of generating the corresponding code, that statement is executed and the result of execution is displayed. So what I've explained here, that is what here in theoretical way we have written. Next, in interpreter, every time the program has to be executed, it is processed and checked for each line. So it is slower than compiled programs. As I've already mentioned, this takes a lot of time because each and every line must be checked. Okay, and for some languages like Java, this is important. For some languages like Java, we have both compiled and interpreted, meaning will be having both compiler at the same time interpreter in Java. Okay, so how this takes place in the sense? So in Java program, it is first compiled. So what happens first? Compilation will take place, which is into the bytecode. Then this bytecode what we obtain is interpreted. This bytecode which is obtained is interpreted. So this happens in terms of Java. So if you look at the speed, compiled program speed is always greater than the speed of an interpreted, because here at once the program has been executed, whereas here the program has been executed by each line. Okay. Now speaking about the advantages, if simple, meaning the code is very simple, then it will be executed at once. Okay. And it is more portable when compared to the compiler. Okay. What is more portable? The interpreter is more portable. And for certain language features, this was supported. Okay. Like for Python and all, this, the interpreter is supported. Okay. So guys, next we'll be discussing about the typical language processing system, meaning how, we convert a high level language to an executable code. So the process is very simple. First, the high level language is being given to the preprocessor, which converts it into pure high level language, which is then given to the compiler that will produce an assembly code, which is further given to the assembler, who generates a relocatable machine code, which is given to the loader or the linker, which then further, produces the executable code. So this flow is not very important, but it's necessary that you know how the transaction or how, the process takes place. Okay. So in preprocessor, we have three responsibilities. That is the macro expansion. The second one is the file inclusion. And the third one is the language expansion. So in macro expansion, what happens? It is very simple. So you will give a, statement. Like already I have here highlighted. This is an example. So here what we will do is we will define pi 3.14. So what this line says is that when you give something like this, hash define pi 3.14, wherever in the code you have the word pi, it's been replaced with this 3.14. Okay, that is what macro expansion basically does. Okay, so the macros are identified and substituted with their respective values. Next comes with the file inclusion. So what file inclusion does is, we have this format that is the hash define stdio.h, right? So this is, you people already know that this has been used in C language, which you have already studied in your initial year. So here, instead of this, a file will be replaced. That is very simple. That's what happens in this file inclusion. Then comes with the language expansion. So language expansion is it is applied. So it's a feature you can imagine that can be applied. So what it does is basically, if you take an example, adding database query facilities to the language. This is a responsibility, right? So this is nothing but the language expansion. Next comes with the compiler. So already we have read what compiler is in a very initial stage itself. Again, we will come and brush it out. Compiler is nothing but which converts high level language into assembly code, meaning the low level language. Okay. Next is the assembler. So assembler is nothing but they convert the assembly language to machine language. Okay. This will be in a mnemonic version of the machine language. And this is very important. Assembler should provide memory location or address to symbols and identifiers. Meaning, suppose we have something like A plus B. Okay, so for this A as well as B, it has to provide either the memory location or the address. Who has to provide? The assembler has to provide. Okay. And load linker, this basically we will be reading in depth in the operating systems. Now you don't require this much. Next we have is the high level language. So what do you mean by high level language? So high level language is basically we'll be writing it with hash define या hash include. Okay. Now what is pure high level language? If we will not be having this hash define and hash include, no, that makes it pure high level language. So the difference between high level language and pure high level language is very simple. In high level language, we have hash define and hash include, whereas in pure high level language, we will not be having any of this. Okay. That is the high level language and pure high level language difference. Next, we'll be discussing about the phases of compiler design. Okay. So what like process we have in the sense? First, we'll be having high level language. Okay. That has been given to lexical analyzer. Okay. What does lexical analyzer do? They will generate tokens. Okay. Which is further given to the syntax analyzer. Okay. Then what syntax analyzer do? They will produce parse tree and they will be given to the semantic analyzer. Okay. Then what happens? The semantic analyzer will produce a semantic parse tree and will be given to an intermediate code generator. Okay. Now in intermediate code generator, a code will be generated which is given to the code optimizer. Okay. Which will optimize the code and will be given to the target code generator. So this is the phase how it takes place. So here we have a symbol table which take care of all these things. So these from high level language to the intermediate code generator, it's the part of the front end. And from the code optimization and the target code generator, we have the backend. And also all these things, error handle is also being taken care of. Okay. Now, what is lexical analyzer, syntax analyzer? We will be reading in a very, brief way. Okay. So as I've already told, lexical analyzer is nothing but it takes an input stream of character and converts it into token. Okay. Now, what is token? It may be a keyword or an identifier, constant or operations. So here you have an example. So see, it's a keyword, an operator, operation, identifiers. So the combination, like see it, whatever, the set of characters it takes, that will be converted into tokens. Okay, that is what lexical analyzer basically does. It is also called as scanner. So lexical analyzer is also called as scanner. Okay. Next we have is the syntax analyzer. Syntax analyzer, from the name itself we know this will check the syntax of the statement whether it's correct or not. Okay. Very simple. Next is the semantic analyzer. So semantic analyzer is nothing but, now you have a variable called A and B. Okay, you have a variable called A plus B. Okay. Now, if A is an integer, and B is also an integer, then easily your result will be in integer and there won't be any issue. So this is what syntax analyzer does. Now imagine if you have A plus B in which A is array and B is some function. Imagine A is array, B is some function. Then how do this operation takes place? So to verify that, the type of, variable you are using, we use semantic analyzer. Okay. So it's nothing but it verifies the type. So which type of variable you are using. So that is basically verified by the semantic analyzer. Okay. Yeah. So next we have is intermediate code generator. So what intermediate code generator does? It generates the intermediate code. Okay. So if you want in detail of this, then you can go through this paragraph. So you can just pause to it and you can go through, because this is not much important, but for your reference, if you want in more depth, then you can pause the video and you can just refer to this content. So next we have is the code optimizer. So what does the code optimizer do is, it reduces the number of lines. Okay, it reduces the number of lines. So what is the main goal? The main goal is to improve efficiency. Of course, imagine you have 10 lines of code. Okay, and you're executing it. So for executing 10 lines of code, for example, let us imagine it takes 5 minutes of time. Okay, but if you have a code of either 5 or 6 lines, then it will take more less time, right? If the time complexity or if the time is less, then your efficiency is more. And that's what code optimizer actually does. Okay, instead of repeating some lines repeatedly, it will actually reduce it. It will actually reduce it. Now I can give a small example to this. Okay, suppose let me say I have A is equal to some BC plus D, and B is equal to A plus BC, and C is equal to some, imagine, B plus BC. Now what is happening? In this line, once BC is executed, again in this line BC is executed, again in this line BC is executed. Instead of this, if I define T to be BC, and once a T in like before line, once T is being executed, and if here instead of BC I will substitute or replace it with a T, then here it's already one time executed. So here directly the value will be added and it does not require to be executed again and again with the same value. Okay, so that's how code optimization takes place. This is just one of the method. So in code optimizer, we have so many methods how we can actually reduce the code. Okay, next and last we have is the target code generator, which basically generates your target code, meaning once your code is, optimized, meaning you have reduced all the lines. Now your code is perfect to be executed. So that is what the target code generator actually mean. So guys, now before starting into the other topic, we need to know what LMD, RMD and peristry are. So basically these topics will be reading in TOC itself, theory of computation. But again here with, since we have not started that series, I will go with basics itself. So LMD means leftmost derivation. RMD means rightmost derivation, and peristry is already it is. What it is, I'll explain in brief. Okay. So you have to know how LMD, RMD and peristries are being, solved and all. So for this, let's take an example. So let me say I have a grammar given something like this. Okay. So to people who doesn't know what this is, in place of E, I can either substitute E plus E or E star E or ID. So from these three places, I can substitute anything according to my convenience. Okay. Now for LMD, RMD, peristry and all, to solve that, they'll be giving us a grammar in such a way, and they'll be giving us a statement such as prove ID plus ID star ID. So like this, they'll be giving us something. Okay. Now using this grammar, we need to prove this line. Okay. So first, let us go with LMD. Okay. So what I'll do is, first I'll consider E is equal, or E implies, first I'll consider the same thing. Okay. E plus E. Okay. Now what do you mean by leftmost derivation? Means that amongst these two, what is the leftmost side? This is the leftmost, right? Leftmost in the sense the left. Left side is this. So first you will substitute this and then go to the right side. Okay, so first preference will be given to the substitution with side, the left side. Okay, so in place of E, I can either substitute E star E or ID. Okay, now since here I have ID, I will substitute in place of E, ID and write the remaining as it is. Okay, I'll write the remaining as it is. Now, this part is being proved. Now I have this part to be proved. So for that, I have 1E. So what can I substitute here so that I will get this as an answer? Okay. Now see, if you see this line particularly, you don't have any left, like you don't have here anything to be, solved or derived. So you have only this part to be derived because this is already derived. You don't have further, this further cannot be derived. So now you are left with this. So only this can be derived. So in this place, what best among these three can I take so that I will get this as an result? So I want multiplication symbol. So I will choose definitely this line. So what I'll do, ID plus, in the place of E, I will substitute this. That is E star E. Okay. Now see, in the leftmost side, I have ID, which I can't further, derive. Here I have E. So to satisfy my statement, I want ID. So can I substitute in place of EID? Yes, I can substitute. So I'll go with ID plus ID star E. At a time, one can be derived. So again, ID plus ID. Now only I have this part to be remained. So again, I'll substitute E with the place of ID. So now what did I get? I got a statement that I need to prove. Okay. So I hope this is clear. Also, we can do one more way. E implies, instead of addition, I can also take multiplication 1. Okay. So here what I can do, again, this symbol I should derive. So in place of E, let me take E plus E. Okay. So I'll write E plus E star E. Okay. Now again I have to substitute the left one first. So instead of this, I will write ID plus E into E. Again in place of E, ID. Again in place of E, ID. Okay. So it's been proved. So now we got two LMDs. This is the first LMD, this is the second LMD, where whatever you take, you'll be getting the statement. Okay. Now let's do for the RMD. Let's now do to the RMD. So RMD is also very easy and very similar. Now instead of choosing the left part, we will choose the right part. Okay. Instead of choosing the left part, we'll be choosing the right part. So what I can do, I can write E implies E plus. Can I take here this one, E star E? Can I take? Yes. So it's E star E. Okay. Now what we will do, again rightmost side itself I can do. So again I'll write E plus E and instead of this E, I will write ID. Similarly, E plus ID star ID. Now I replaced this with ID. And finally, ID plus ID star ID. Okay. Now let's see, can we do it again with star? Can we do it with star? Yes, we can do it. So see, let's, what we have to do, rightmost side itself we have to take. So I'll keep E as it is. Okay, I'll keep E as it is. And in place of E, I'll substitute ID. What I'll do, I'll substitute ID. And then what I'll do, in place of this E, I'll substitute E plus E into ID. In place of this, I'll substitute E plus E. Why? Because here my rightmost side is already derived. I can't further divide. So now I'll go with this. Okay. Now I'll just replace the rightmost side, that is this, with ID. And then this with ID. So now I have proved my statement. And this is how LMD and RMD has been done. So I hope this is clear and simple. Okay. Next is the parish tree. Okay. So guys, for parish tree, first I'll take E. Okay. This E can be written as E plus E. Okay. This can be written as E plus E. So if I take it with respective to LMD, I have to first solve this. So here I'll write ID. Okay. And this I will again further divide into E star E. Okay. In which here again I'll replace it with ID and this with ID. Okay. Now again, if you do with RMD, then first you will consider E star E. First you will consider E star E, because right side you're gonna do. So here you will first go with ID and then here you will go with E plus E, which further you will go with ID and then ID. So this is how parish tree has been done. So I now hope you understood what is parish tree or how it has been done, RMD and LMD. Okay. Guys, now just remember this point. If a grammar generates more than one LMD or one RMD or one parish tree for a string, then it is called as ambiguous. Okay. So guys, so far what all I explained has covered your complete theory part, and from the next session, that is from the next video, we'll be starting with the problems. So in compiler design, if you look at, then in 100%, 80 to 90% will be getting the problems itself based on the parser, and remaining 10% will be getting the theory question. Most probably theory questions with whatever I explained till now has not been asked, like very rarely in entire GATE. Some 3 questions majorly might have been asked, but most probably they haven't asked till now. But you know why I have explained all this is because tomorrow when we'll be solving problems, you require some conceptual knowledge that you will be required while solving the problems. So for that part, I have explained the complete theory. At the same time, if by chance, if they ask any question related to theory, then with whatever I explain, you people can attempt. So with that confidence, I have, thought all this theory part. Else I could have directly gone to the problems, but I want you people to go with the conceptual knowledge as well. And if you ask me why I am so confident with whatever theory I have, explained is enough, because I basically refer to RBR sir. That's of the Ravindra Babu Ravala sir. So I have completely referred his lectures, his notes, and itself I am explaining, things. So to people who doesn't actually know him, he has a lot of experience, and also he is being called as God of compiler design, because the experience that he holds and the knowledge he has is that far. Also, his compiler design, books and all are very popular, like the notes. If you have seen people whoever explains computer networks, or the compiler designs, theory of computation, and etc., all prefer Sir's notes itself. And yes, I have also preferred Sir's notes. I have actually learned things from him. So that's the reason, with much confidence, I am able to explain you people. At the same time, I'm able to tell things to you people. So yes, guys, for theory, if you prepare this much, it's more than enough. And yes, if you want notes in Google, you can actually type out Sir's notes, RBR Sir's notes. At the same time, in YouTube, you also have Sir's channel, where if you want, you can go and watch videos where Sir will also be explaining in English itself. Also, if you people have any doubts regarding whatever I have taught till now, else if you people haven't understood anything, you people can actually put your comments in the comment section, where I'll be seeing it, and I will definitely, reply to it also. Also, we'll be providing our Instagram account, where whatever queries you have, you can approach us through the account. So I hope so far the video was helpful and you people have understood all the topics. From tomorrow, definitely we'll be starting with the, problems. And yes, you may feel bored till now because it was completely theory, and, we were going it with a fast pace. But from tomorrow, we'll be having completely problems. So you will, understand things very clearly. At the same time, we'll be going it in a very medium pace, so that anyone can easily understand. And yes, of course, from tomorrow's lecture of compiler design, everything will be interesting and you won't feel bored. I can assure you that. Yes, guys, if you liked our content, so please do subscribe, like, and share to your friends, so that they can also gain knowledge. At the same time, I want you people to comment whatever you feel, so that we'll understand and we'll try to improve. Thank you, guys.